Today we will discuss conditions for consistency for a pair of linear equations in two variables. These are the intersecting lines. They have one common point. So we can say it has one solution, right? So these are parallel lines. They do not meet at any point, correct? So they do not have any common point. Therefore, no solution for the parallel lines. The third one is coincident line. Yes, so the coincident line has infinite common points. Therefore, they have infinite solutions. Okay. So every point on the line is the solution. Okay. So therefore, they have infinite solutions. We have already seen consistent system of linear equations, right? So what is consistent system? If you have at least one solution, it is said to be a consistent system of linear equations. What comes under consistent system? Intersecting lines, because intersecting line have one solution, right? The next is coincident lines. Coincident line. Yes, coincident line have infinite solutions. Correct? So, intersecting line and coincident lines come under consistent system of linear equations. Okay? Because they have at least one solution. Okay? So, the intersecting line is called independent consistent system because the two lines are independent. Okay, and the coincident line is a dependent consistent system because the two lines are on one other, right? So if the first line moves, the second line also moves. They depend on each other. So it is said to be a dependent consistent system. Coincident line is said to be dependent consistent system. So what about the parallel lines? This is the parallel lines. So what about the parallel lines? So the parallel lines come under, okay, inconsistent system. Okay. So if the system has at least one solution, it is said to be a consistent system. If the system has no solution, okay, it is said to be an inconsistent system. So parallel lines come in inconsistent system. Okay. Next we will see condition for consistency. Okay. This a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 is equals to 0 is a general form of a pair of linear equations in two variables. Now we will see what are the conditions for the pair of linear equations. Okay. So the first condition is, okay, the first condition is the ratios of coefficients of x will not be equal to the ratios of coefficients of y. Okay. So the first condition is ratios of coefficients of x, that is a1 by a2 will not be equal to ratios of coefficients of y, that is will not be equal to b1 by b2. Okay. So this condition is for the intersecting lines. Intersecting lines have one unique solution. Okay. So the second condition is ratios of x coefficient and ratios of y coefficient and ratios of constant terms are equal. Okay. So a1 by a2 is equals to b1 by b2 is equals to c1 by c2. So this is the second condition. So this will be for the coincident lines. Coincident lines. Coincident lines have infinite solutions. So the third condition is A1 by A2 is equals to B1 by B2 but is not equals to C1 by C2. Okay. So this is the third condition, and this condition is for parallel lines. Parallel lines have no solution. Okay. So these are the three conditions for the consistency. Okay, if you just remember these three conditions, by seeing the question, you can say if they are intersecting lines, coincident lines, or the parallel lines. Okay, if they are intersecting lines, A1 by A2 will not be equal to B1 by B2. Okay, so if they are coincident lines, A1 by A2 will be equal to B1 by B2. That will be equal to the ratios of the constant term, which is C1 by C2. Clear? And if it is a parallel lines, that will be A1 by A2 will be equal to B1 by B2, will not be equal to C1 by C2. Okay, so these are the three conditions for the consistency. Now we will see an example problem. Check whether the given pair of equations represent intersecting lines, parallel lines, or coincident lines. Find the solution if the lines are intersecting. Okay, so they have given us the pair of linear equations. We need to find whether it is an intersecting, parallel, or coincident lines. Okay. So from the conditions for consistency, we know that if it is a intersecting lines, what is the condition? A1 by A2 will not be equal to B1 by B2. Correct? And if it is a coincident, what is the condition? A1 by A2 is equals to B1 by B2 is equals to C1 by C2. Right? And if it is a parallel lines, what is the condition? A1 by A2 is equals to B1 by B2 is not equals to C1 by C2. Comparing these two equations with the general form, you will get A1 is equals to 2, B1 is equals to Y, C1 is equals to minus 5. Yes, in the same way, A2 is equals to 3, B2 is equals to minus 2, C2 is equals to minus 4. Now we will see the ratios of A1 by A2. A1 by A2 is equals to, what is A1? That is 2 by A2 is 3. It is 2 by 3. Okay. B1 by B2 is, B1 is, which is 1, right? B1 is 1. B1 is 1 by B2 is minus 2. We will see for C1 by C2. What is C1? C1 is minus 5 by C2 is minus 4. If you see A1, A2 and B1 by B2, you can say that A1 by A2 is not equal to B1 by B2. So we can say that A1 by A2 is not equal to B1 by B2. So what is A1 by A2? Which is 2 by 3 is not equal to 1 by minus 2. So this is the condition for the intersecting lines. So we can say the above given pair of linear equations A1 by A2 is not equal to B1 by B2, okay, which is 2 by 3 is not equals to 1 by minus 2. Therefore, they are intersecting lines, okay. So, we can say the given equations are consistent. Now, if it is an intersecting line, we need to find the solution for the intersecting lines, right? Let us plot a graph and find the solutions for the intersecting lines. As I told you, if you just have 2 points for x and y, it is enough to draw a straight line, okay? So the first equation is 2x plus y minus 5 is equals to 0. So if you take x is equals to 0, you will get 2 of 0 plus y is equals to 5, y is equals to 5. So if x is equals to 0, you will get y is equals to 5. If you take y is equals to 0, okay, if you take y is equals to 0, what happens? See, if you take y is equals to 0, this will be 2x plus 0 is equals to 5. You will get it in a decimal points, right? X is equals to 5 by 2. Okay, we will try to avoid decimal points. So, for that, I will take y is equals to 1. If y is equals to 1, this will be 2x plus 1 minus 5 is equals to 0. 2x minus 4 is equals to 0. 2x is equals to 4. X is equals to 4 by 2, which is 2. Okay, when y is equals to 1, you will get x is equals to 2. Now, let me just take it in a points. A of 0, 5 is 1 point and B of 2, 1 is 1 point. Now, let us take for the next equation, that is 3x minus 2y minus 4 equals to 0. So, when you put x is equals to 0, this will be 3 of 0 minus 2y is equals to 4 minus y is equals to 4 divided by 2, okay, which is 2. Y is equals to minus 2, okay. So, when x is equals to 0, you will get y as minus 2. If you take y is equals to 0, this 2y will be 0, right? This will be x is equals to 4 by 3. You will get a decimal point, okay, right? So, we will try to avoid a decimal point. So, let us take y is equals to 1. If y is equals to 1, this will be 3x minus 2 of 1 minus 4 is equals to 0. 3x minus 6, right? Minus 2 and minus 4 is minus 6 is equals to 0. So, 3x is equals to 6. I am just sending minus 6 to RHS. So, x is equals to 6 by 3, which is 2. Okay. So, when y is equals to 1, you will get x is equals to 2. So, we can take this points as C of 0, minus 2 and D of 2, 1. Now, let us plot a graph. So, what is the first point? That is 0 and 5. So, 0 on the x-axis, 5 on the y-axis, which is here. So, this is your x-axis and this is your y-axis. Okay. So, the next is 2 and 1. 2 on the x-axis and 1 on the y-axis, which is here. Okay. So, when you just join these 2 points, you will get something like this, right? This is a point A and this is B. And the next one is 0 and minus 2. 0 on the x-axis and minus 2 on the y-axis, which is here. The next one is 2 and 1. 2 on the x-axis and 1 on the y-axis, which is here. Okay, the same point. So if you join these both, we'll take these 2 points as C and D. You can see that the graph is a intersecting lines, right? So the 2 lines intersect or meets at single point, right? So that point P of x and y is the solution of a given pair of linear equations. Okay, so what is the P? P of 2, 1. This is the solution for the given intersecting lines. This is, or you can say this is the solution for the given pair of linear equations. Okay. So we can say that the unique solution for the pair of linear equations is 2, 1. We will solve next example. Check whether the following pair of equations is consistent. Verify by a graphical representation. We need to see if pair of equations is consistent. Then we need to verify by a graphical representation. Okay. We know the conditions for consistency. If it is a intersecting lines, what is the condition? That is A1 by A2 is not equal to B1 by B2. Yes, if it is a coincident, line, then what is the condition? A1 by A2 is equals to B1 by B2 is equals to C1 by C2. Yes, and if it is a parallel lines, what is the condition? A1 by A2 is equals to B1 by B2 is not equal to C1 by C2. So these are the conditions for the consistency, right? Now we will check which condition satisfies. So from the given pair of equations, if we compare it with the general form, A1 is equals to 3, B1 is equals to 4 and C1 is equals to 2. So A2 is equals to 6, B2 is equals to 8 and C2 is equals to minus 4. This is also C1 is equals to minus 2. Okay, just write it in a general form. 3x plus 4y minus 2 is equals to 0 and 6x plus 8y minus 4 is equals to 0. Right? Now let us see which condition satisfies. So now let us take A1 by A2 first, which is A1 by A2 is 3 by 6. If you cancel it, 3 ones and 3 twos, right, which is 1 by 2. And if you take B1 by B2, which is 4 by 8, again it is 1 by 2. Okay, if you take C1 by C2, which is C1 is minus 2 and C2 is minus 4, which is again 1 by 2. All the three ratios are equal. That is, ratio of A1 by A2 is equal. B1 by B2 is 1 by 2 and C1 by C2 is also 1 by 2. So if all the three ratios are equal, then it is a coincident lines, right? So therefore we can say A1 by A2 is equals to B1 by B2 is equals to C1 by C2. Okay. So this is the condition for the coincident lines. So the given pair of linear equations are consistent. Okay. Okay. So if they are coincident lines, they have infinitely many solutions. Okay. Now let us verify by a graphical representation, x and y. So 3x plus 4y is equals to 2. So if I take x is equals to 0, okay, if I take x is equals to 0, this will be y is equals to 2 by 4, which is 1 by 2. You will get a decimal point, right? So as I told you, 0.5 or 1.5 or 3.5, those are easy to plot on a graph. So if you get 1.1 or 2.1 or 3.7, okay, try to avoid those points and try to take a whole number. If x is equals to 0, this will be 3 of 0 plus 4y is equals to 2, which is 4y is equals to 2. Y is equals to 2 by 4, which is 1 by 2, 0.5. If you take y is equals to 0, this will be 2 by 3. So we will try to take a different value for y. If you take y is equals to 1, this will also be the same value. So we'll take y is equals to, we'll try to take y is equals to 2. Let us see what value do we get for y is equals to 2. If it is y is equals to 2, this will be 3 of 3x plus 4 of 2 is equals to 2. 3x, if I send 8 to RHS, this will be minus 8. So 3x is equals to minus 6. X is equals to minus 6 divided by 3, which is minus 2. So if y is equals to 2, you will get x is equals to minus 2. So let me just take these points as a of 0, 0.5 and b of minus 2, 2. So the equation is 6x plus 8y is equals to 4. If you take x is equals to 0, this will be 6 of 0 plus 8y is equals to 4. 8y is equals to 4. Y is equals to 4 by 8, which is 4 ones and 4 twos, which is 0.5. We can consider this point because 0.5 is easy to plot it on a graph. Okay. So if you take y is equals to 0, if you take y is equals to 0, this will be 4 by 6, right? So we will try to avoid that. We will see taking y is equals to 2. If it is y is equals to 2, 6x plus 8 of 2 is equals to 4. 6x plus 8 2s is 16 is equals to 4. 6x is equals to 4 minus 16. 6x is equals to minus 12. X is equals to minus 12 by 6, which is minus 2. Okay. So when y is equals to 2, you will get x is equals to minus 2. So this will be c of 0, 0.5 and d of minus 2, 2. Now let us plot it on a graph. So the first one is 0 and 0.5. So 0 on the x-axis and 0.5 on the y-axis, which is here, right? This one. Okay. This is the point A. And the next is minus 2 and 2. Minus 2 on the x-axis and 2 on the y-axis, which is here, right? If I join these 2 points, you will get something like this. Correct? This is your point B. Okay. Now, the next one is 0, 0.5 again. So, 0, 0.5 is here. And the next one is minus 2 and 2. minus 2 and 2 is also here. Okay, so you will get the same. If you join these two points, you will get the same line, right? You will get a same line. So this is C and this is D point. So we can say that they are coincident lines, right? And they have infinitely many solutions. See, since I have taken 2 points, okay, the 2 points are on the same line, right? The coincident line. Okay, so if you take more points, they will be on the same line. So the coincident lines have infinitely many solutions. Okay, now we will solve a word problem. The perimeter of a rectangular plot is 32 meters. If the length is increased by 2 meters and breadth is decreased by 1 meter, the area of the plot remains the same. Find the length and breadth of a plot. So, let us assume length be L and breadth be B. Okay. So, he has given perimeter of a rectangular plot. Perimeter of a rectangular plot is 32 meters. Right? So, what is perimeter of a rectangle? Perimeter of a rectangle is 2 into L plus B. Correct? Which is 32. So, if you cancel 2 and 32, which is 2 ones and 2 sixteens are 32. This will be L plus B is equals to 16. Correct? So, this is your equation 1. Now, he says that length is increased by 2 meters and breadth is decreased by 1 meter. So, if you increase the length by 2 meters, length is increased by 2 meters. Right? So, if the length is increased, that will be length is increased by 2 meters, that is L plus 2. So, breadth is decreased by 1 meter, that is B minus 1. Okay, that is breadth is decreased by 1 meter, which is B minus 1. Then he says area of the plot remains the same. Area of a rectangular plot remains the same. So, what is area? Okay, what is area? Area will be L into B. Right? Area of a rectangle will be L into B. Right? So, he says that L plus 2, okay, length is increased by 2 meters and breadth is decreased by 1 meter and the area remains the same, which is LB. We need to multiply this both and simplify, which is LB, L into B is LB minus L, L into 1 is minus L plus 2 into B is 2B minus 2 into minus 1 is minus 2, which is LB. We will get this LB to left hand side, that is LB minus LB minus L plus 2B minus 2 is equals to 0. So, minus LB plus LB will get cancelled. Okay. So, the equation, this is minus L, right? So, if we multiply with minus, that will be L minus 2B plus 2 will be equals to 0. Okay. So, this is your equation 2. Now, we got equation 1 and equation 2. Let us simplify. If you put L is equals to 0, okay, B will be 16, right? So, if you put B is equals to 0, L will be 16. If you take L is equals to 0, that will be 0 plus B is equals to 16, B is equals to 16, right? This is a larger number. right? So we will try to take smaller values. Okay, so for that we will try to take L is equals to 8. Okay, if you put L is equals to 8, that will be L is 8 plus B is equals to 16. B is equals to 16. I will send plus 8 to RHS, that will be minus 8. You will get B is equals to 8. Okay, so 8 is little smaller value to plot it on a graph, correct? So when L is equals to 8, B will be 8. Now let us take B value. So if you take B is equals to, see, if you substitute B is equals to 1, 2, 3, 4, 5 or 6, you can decrease the number 16 to smaller number, right? So let us try to take B is equals to 6 and see. That will be, if B is equals to 6, L plus 6 is equals to 16. L is equals to 16 minus 6, we will get L is equals to 10. Okay, so when B is equals to 6, you will get L is equals to 10. A of 8 comma 8 and B of 10 comma 6. So if you take L is equals to 0, right, if you take L is equals to 0, this will be 0 minus 2B is equals to minus 2. B is equals to minus 2 divided by minus 2, which is 1. Correct? So when L is equals to 0, you will get B as minus 1. And when you take B is equals to 0, when you take B is equals to 0, when B is 0, L minus 2 of 0 is equals to minus 2, which is L is equals to minus 2. Okay, so when B is 0, you will get L as minus 2. This is not minus 1, this is plus 1, because minus minus will also get cancelled, which is B is equals to 1. Okay, now let us plot the points. A is 8 and 8. 8 on the x-axis and 8 on the y-axis, which is here. Okay, the next one is 6 comma 10. 6 on the x-axis and 10 on the y-axis, which is here. Okay, so when you join these 2 points, you will get the line like this, right? Straight line. This is A and this is B. So the next one is C is 0 comma 1. 0 on the x-axis, 1 on the y-axis, which is here. This is C. And the next one is minus 2 and 0. Minus 2 on the x-axis and 0 on the y-axis, which is this one. Okay. So when you join these both, you will get like this. The two straight lines is meeting at one common point, right? So this common point P will be the solution of a given pair of equations. Okay, P of x and y. So I think we have taken L and B, right? So L and this is B. So we can take it as L and B. P of L and B, that is 10 comma 6. So this is here meeting at 10 and this is meeting at 6. Okay, so 10 and 6 is the solution of a given pair of linear equations. Okay, so therefore what is 10 here? 10 is length, right? Therefore length of a rectangular plot 10 meters. Okay, length of the plot is 10 meters and breadth of the plot is 6 meters. Okay, clear? If you have any doubts on the chapter, pair of linear equations, put them on the comment section below. I will respond to them.